Good morning, students. This is your teacher Neelam Elawat, and today we'll be talking about the convex lens and drawing ray diagrams. See, yesterday we have talked about the rules. We'll be repeating them once again. So before we start, keep your books, notebooks ready, okay? And have your sketch pen also so that you can underline the important points. Let's start with the topic, dear students. In the last class, we have discussed about 3 rules. The first rule says that if a ray is coming parallel to the principal axis, right, it will go through the focus, that is F2. This is a rule number 1. Second is, if the ray is coming through optical center, it will go straight without any deviation, right? It will go straight without any deviation. And third, if the ray is coming through F1, after refraction, it will become parallel to the principal axis. So these are your 3 rules, and out of these 2 rules, we will use 2. Means we will use 2 rays for drawing the diagrams. We will use how many rays? 2 rays for drawing the diagrams. Okay. I hope you understood. How many rays we'll be using? We'll use only 2 rays for drawing the diagrams. Now coming to the sign convention for the spherical lenses, we have done for the spherical mirrors. Same is applicable to the spherical lenses also. The only difference is that you will have O instead of P. In mirror we have pole, but in lenses we have optical center. So all distances will be measured from the optical center. All distances will be measured from the optical center. Clear? All distances will be measured from the optical center. Second, this line, which is called the principal axis will serve as x-axis. Principal axis will serve as x-axis, right? Principal axis will serve as x-axis, and all distances will be measured from this O. O is your optical center. O is your optical center. So all distances will be measured from the optical center. All distances will be measured from the optical center. So here is this optical center, okay? So distance towards the left of the optical center are referred to as negative distances. They will be taken as negative distances. All distances measured towards the right of the lens or towards the right of the optical center will be taken as positive. Distances above the principal axis will be taken as positive. Distances below the principal axis are taken as negative. So 6 rules, okay? The focal length of convex lens is positive, and the focal length of the concave lens is taken as negative, right? Now before starting with the diagrams, understand this. We'll place the convex lens, then we will have F1, then we'll have F2, then 2F1, then 2F2. Instead of 2F2, you can write C1 and C2. You can use any of the terms. Either you use 2F1 and 2F2, or you use C1 and C2. Now students, let's start with the first diagram. Now suppose your object is at infinity. So your object is at infinity. From infinity, all rays will come parallel. All rays will come parallel, right? And after refraction, they will meet at a point which is called the focus, that is F2 here, right? All rays will meet at F2. So where is the object? The object is at infinity. And where is the position of the image? At F2. The nature of the image is real and inverted. The nature of the image is real and inverted, and it is point sized. Okay. So these are the points related to the image. So object is placed at infinity, image is formed at f2, it is real, it is inverted, and it is point sized. Okay, let's see the next diagram. Now here we'll see that the object is beyond f2, beyond 2f1, sorry, or you can say c1. हमने ऑब्जेक्ट को c1 के बाद रखा है, पीछे रखा है, तो कहाँ क्या होगा, इमेज कैसे बनेगी, ठीक है. दिस वी हैव टू सी. नाउ फर्स्ट विल टेक अ रे पैरेलल टू द प्रिंसिपल एक्सिस. अगर हम पैरेलल रे देते हैं तो कहाँ मिलेगी, वो f2 से पास होगी. एंड सेकेंड रे वी विल टेक द रे विच इज गोइंग थ्रू द ऑप्टिकल सेंटर. अब ये दोनों रेज जो हैं वो f2 और 2f2 के बीच में मिलती है. कहाँ मिलती हैं, 2f2 और यू कैन से C2 सॉरी, f2 एंड C2 के बीच में मिलती हैं. क्लियर. तो यहाँ हमारी इमेज बनेगी. आप देख सकते हैं, फॉर द ऑब्जेक्ट आई हैव यूज्ड अ पर्सन, अ फोटो ऑफ द पर्सन आई हैव यूज्ड. एंड यहाँ देखिए इमेज कैसी है, उल्टी है, राइट. सो लेट्स राइट डाउन द नेचर ऑफ द इमेज. हम इमेज की नेचर लिखते हैं कि नेचर कैसी है. ठीक है, चलिए लिखते हैं नेचर. सबसे पहले तो इमेज कहाँ बनी है, टेल मी दी वेयर इज द इमेज. द इमेज इज बिटवीन f2 and c2. So you will write image is formed between f2 and c2. Then what is the nature? Nature कैसी है, कैसी है इमेज, इमेज इन्वर्टेड है. कैसी है, इन्वर्टेड है और रियल है. इमेज इज इन्वर्टेड एंड रियल. इमेज इज इन्वर्टेड एंड real. Clear. Then what is the size of the image? Size is, the image is it smaller or bigger? The size, it is smaller, right? It is smaller. It is smaller than the image, right? So image is between f2 and c2 and it is inverted and real and size is smaller, right? The size is smaller. Now see, the object is at 2f1. The image object is at 2f1. We are placing the object at 2f1. Again we'll take a ray parallel. The parallel ray will pass through the f2 and this ray will pass to optical center. They will meet at 2f2, or we can say the object is at c1, image is at c2, right? Now let's see, where is the object, at c1. The image object is at c1. So where is the image? The image is at C2. Image is at C2. Clear? And what is the nature of the image? What is the nature of the image? The image is inverted and real. The image is inverted and real. Okay, the image is inverted and real. Image is inverted and real. Okay, and it is size. What is the size? It is of equal size. It is of same size. जितनी ऑब्जेक्ट है उतनी ही इमेज है. ठीक है, ये सेम साइज की इमेज बनेगी. और ये कंडीशन बहुत इंपॉर्टेंट है, बोर्ड में बहुत बार पूछते हैं कि व्हाट इज द कंडीशन वेयर द साइज ऑफ इमेज इज इक्वल टू साइज ऑफ ऑब्जेक्ट, राइट. नाउ लेट्स कम टू योर होमवर्क डियर. You will draw these ray diagrams beautifully using a sharp pencil. You will write all the points about the object and the nature of the image, and then you will click the photo and send to me, right? Okay, dear students? Very good. So I hope you will complete, you will keep yourself safe, right, and enjoy your studies. Goodbye everyone.